Hi guys, I'm Niveta. In this video, I'm going to teach you on Jacobian transformation concept. Okay, one problem based on Jacobian transformation concept. In cylindrical polar coordinates, x is equal to cos phi is equal to rho sin phi, z is equal to z. Show that dou of x comma y comma z divided by dou of rho comma phi comma z is equal to rho. That is what we have to prove. Basically, what is cylindrical polar coordinates means, actually polar coordinates means it is a representation of a particular point by using the distance and angle. Okay, so in normally we used to study like polar coordinates means r comma theta, right? R is a distance and theta is the angle. Okay, like a Cartesian coordinate means x comma y. We are having ordered pair like x comma y, that comes under Cartesian coordinate, but in polar coordinate it comes like the distance and the angle. So what is meant by cylindrical polar coordinates means simple extension of 2D polar coordinates to 3D. Okay, so see here I am having a point like M, so I can represent this M by the distance rho and the angle phi, right? I can mark this point M by the distance rho and the angle phi. Suppose if I want to consider a point P here, that is x comma y comma z here in Cartesian coordinate we used to denote it by x comma y comma z, but in cylindrical polar coordinates I used to denote it by rho comma phi comma z. So z is the length. Okay, so it is what length. So rho comma phi comma z, which is which we normally used to tell the polar coordinates. So we have to prove this. Okay, so I am going to consider this left hand side alone. So when you write the Jacobian transformation, we have to write this in determinant form. So determinant of what will come is dou x by dou rho. Okay, then dou x by dou phi, then dou x by dou z. In first row and all, according to that x only it will come. In second row according to this y, in third row according to this z will come. Okay, that is dou y by dou rho, dou y by dou phi, dou y by dou z, then dou z by dou rho, dou z by dou phi, dou z by dou z. Likewise it used to come. So we are going to find out those values. So I am just considering this x, y, z values here. X is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. First of all, I have to find for this dou x by dou rho. Okay, so here I am having this x with respect to rho. If I find this is partial differentiation, right? So I have to differentiate this rho alone. So when I differentiate this, I will get 1. So it will be like cos phi only. Then if I find the values like dou x by dou phi means I have to differentiate with respect to phi. So if I differentiate cos phi, I will get minus sin phi. So rho I should not touch rho. So it will be like minus rho sin phi will come. Then dou x by dou z means here I am having no z, so it will be like 0. On the whole it will be like 0. We are partially differentiating, no? So then here it's y, so dou phi by dou rho means rho will get 1, so it's like sin phi will come. Then dou y by dou phi means when you differentiate sin phi you will get cos phi, so it will be like rho cos phi. Then dou y by dou z means it will be like 0 here because there is no z, no, so it will be like 0. Then the last thing is z is equal to z, so dou z by dou rho means it is like 0, there is no rho, right? So it will be like 0. Dou z by dou phi means there is no phi, so it will be like 0. Dou z by dou z, which is 1 because we are having z, so it will be like 1. So we have to substitute all these values in this formula. If you substitute, then what you get is we have to find the determinant value. So okay, so what would be the determinant value? Cos phi. If you have to cancel this row and this row, you will get what? 1 into rho cos phi, 1 rho cos phi minus 0. Okay, minus of this term will come, right? So minus of minus rho sin phi into this 1 into sin phi is sin phi, and then minus 0 will come. Then plus 0 into any number is 0. So you have to bring this here. So it will be like rho cos square phi will come. Okay, this minus into minus plus will come. And when you multiply this, it will be like plus rho sin square phi will come. so you have to take this row common outside. Cos square plus 5 plus sin square 5 will come, which is equal to 1, which is equal to rho. Okay, therefore we have proved this value, hence proved. Thank you for watching.